Matrix. A matrix is a mathematical object consisting of an arrangement of numbers based on rows and columns. The matrix is one of the studies in algebra. If we have two square matrices A and B with the same size, then the sum A plus B is the matrix obtained by adding the entries of B to the corresponding entries of A. Multiplication of A and B, that is, multiply by corresponding row and column entries together, and then add the resulting product. The transpose of A is defined to be matrix that result by interchanging the rows and columns of A. That is, the first column of A transpose is the first row of A. The second column of A transpose is the second row of A, and so forth. That is sum of matrix operation. Matrix theory has many uses for solving various problems in mathematics, science, business, technology, and many more. In this video, I will explain how matrices are useful in computer graphics, especially in digital image processing. In today's, we use digital image in everything and everywhere. The images you see on internet pages and the photos you take with your mobile phone are examples of digital images. But do you know how these images were formed? A digital image, when you look real closely, is just made up of a bunch of pixels each of a single color. Those colors can then be represented by some numerical value. If this square image consists of 1 million pixels, then it can be represented by a 1000 by 1000 matrix. Another example, this image consists of 100 pixels, so it can be represented by a 10 by 10 matrix, whose elements are the numbers 0 and 1. These numbers specify the colors of each pixel. The number 0 is indicate black, and the number 1 is indicate white. Digital image using only two colors like this are called binary image or Boolean images. Then, if we have grayscale image, can also be represented by matrices. Each element of the matrix determines the intensity of the corresponding pixel. For convenience, most of the current digital files use integers numbered between 0 to indicate black, the color of minimal intensity, and 255 to indicate white, maximum intensity. Other types of images, named color images. Color images can be represented by three matrices. Each matrix specifies the amount of red, green, and blue that makes up the image. This color system is known as RGB. The elements of these matrices are integer numbers between 0 and 255, and they determine the intensity of the pixel with respect of the color of the matrix. Furthermore, since matrices can represent digital images, we might ask how operation on their element affect the corresponding image. If we consider a binary image A, this image can be represented by a matrix. Let's say matrix A, and we know that matrix B is the transpose of matrix A, and that image B corresponds to the transpose of matrix A. So, when the representation matrix for image A is transposed, a new image is obtained, that is, image B. Another application of matrices for digital images processing is the effect of filters on images. The process of applying this image effect is also known as image convolution. One of them is the blur effect. The convolution operation, denoted by symbol star, can be described like this. That is, by multiplying the corresponding entries and then adding up the result. This matrix is represent the initial image, and this matrix is called the kernel matrix. which is a matrix that functions as a filter effect that will be applied on the image. For example, we will apply a blur effect to this image. The kernel blur effect is like this. First, to find the colors of this pixel, we must to find the convolution result of this matrix. Multiply the entries corresponding to the kernel matrix and then add up the result. Same for this pixel, and so on, such that this image is obtained. So those are some of the uses of matrices in computer graphics, especially in digital image processing. Thank you.